Hello everyone, welcome to Augmented. In this session, we will be learning about decision tree classification algorithm. By the end of this session, you should be able to understand what is a decision tree classification algorithm, why use decision trees, decision tree terminologies, how does decision tree algorithm work, attribute selection measures, advantages of decision tree, and disadvantages of decision tree. I'm excited to get started and I hope the same from you. Let's get started with what is decision tree. So decision tree is a supervised learning technique that can be used for both regression and classification problems, but mostly it is preferred to solve classification problems. It's a tree structured classifier where internal node represents the features of dataset, branches represents the decision rules, and each leaf node represents the outcome. In a decision tree, there are two nodes, which are the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are output of those decisions and do not contain any further branches. The decision of tests are performed on the basis of features of given data set. Now let's see what is decision tree classification algorithm. So it's a graphical representation for getting all the possible solutions to problem or decision based on given conditions. It's called decision tree because similar to tree, it starts with root node, like it expands on further branches and construct a tree-like structure. And in order to build a tree, we use the CART algorithm, which stands for classification and regression tree algorithm. A decision tree simply asks a question and based on answer yes or no, it further splits the tree into subtrees. So decision tree is a flowchart that can help you make decisions on previous experience. Now let's have a look at this diagram of decision tree classification algorithm. So the first node we have is the root node or decision node, and then each of the decision nodes will have subtrees like leaf node, and leaf node here are the branches, and they don't have further branches. So you can see here it is making subtrees, like this is one of the subtree, this is another subtree, and this is another subtree, where decision node is having one or more leaf nodes, and leaf node will not have any further nodes. Now, why use decision trees? There are various algorithms in machine learning, so choosing the best algorithm for given data set and problem is something really important. Here, the main point to remember while creating a machine learning model is below are the two reasons for using the decision tree. It usually mimics human thinking ability while making a decision, so it is easy to understand. And the logic behind decision tree can be easily understood because it shows like a tree like a structure. Now let's understand the decision tree terminologies. So we first have root node. Root node is from where the decision tree actually starts, and it represents the entire data set, which further gets divided into two or more homogeneous sets. Then we have leaf node, that are the final output node, which will not have any further branches, and the tree cannot be segregated further after getting a leaf node. Then we have splitting. Splitting is the process of dividing the decision node or root node into subnodes according to given conditions. Then we have branch or subtree. A tree formed by splitting the tree. And then pruning is the process of removing unwanted branches from the tree. Then we have parent or child node. The root node of the tree is called parent node, and the other nodes which cannot be further divided are known as leaf node or child nodes. Now, how does decision tree algorithm work? So, in a decision tree for predicting the class of given dataset, algorithm starts from the root node of the tree. And this algorithm compares the value of root attribute with the record real dataset attribute, and based on comparison, follows the branch and then jumps to the next node. For the next node, algorithm again compares the attribute value with other subnodes and then it moves further. It continues the process until it reaches the leaf node of the tree where it cannot be further divided, and it actually reached to some outcome. And in order to make the decision tree, all the data has to be numerical. Now let's understand the steps in decision tree. So we'll begin the step one is begin the tree with root node say yes, which says yes, which contain the complete data set. Then we'll find in the step 2, we'll find the best attribute in the dataset using attribute selection measure, that is ASM. So we will be looking at this in detail. Then we have step 3, dividing the S into subsets that contains possible values for best attributes. Then we have step number 4, where we generate the decision tree node which contains the best attribute. And then step number 5, recursively making new decision trees using the subsets of data created in step 3. And then continue this process until a stage is reached where you cannot further classify the nodes and the final nodes as leaf node. Now let's have a look at the attribute selection measure. That is the third step of our decision tree. So while implementing decision tree, one of the main issue arises that how to select the best attribute for the root node and for subnodes. So in order to solve such problems, there is a technique called ASM, or attribute selection measures. By doing this measurement, we can easily select the best attribute for the node of the tree. There are two popular techniques for this. One is information gain and then finding the Gini index. Now, what exactly is this information gain? So this information gain is measurement of changes in entropy after the segmentation of data set on an attribute, and it calculates how much information a feature provides us about a class. So according to the value of information gain, we can split the node and again build a decision tree. Now here the decision tree algorithm tries to maximize the value of information gain, and a node or attribute having the highest information gain is the one which is split first. So information gain can be calculated as entropy of S minus weighted average into entropy of each feature. Now, what exactly is this entropy? It's a metric to measure the impurity in a given attribute. It specifies randomness in data. So, entropy is calculated as entropy of S equals minus P of S log to P of S minus P of no log to P of no. And then we have Gini index. So, it's a measure of impurity or purity used when creating a decision tree in the classification and regression tree algorithm. An attribute with low Gini index should be preferred as compared to high Gini index. For information gain, we will be using an attribute which has maximum value that need to be split first. And for Gini index, we will look for low Gini index that should be preferred as compared to the high Gini index. It only creates binary splits. The CART algorithm uses Gini index to create binary splits, and it can be calculated using the below formula. That is Gini index equals 1 minus summation p square of c. Now let's understand what is pruning, getting an optimal decision tree. So pruning is nothing but a process of deleting the unnecessary nodes from a tree in order to get optimal decision tree. So while you're building the tree, you might be getting some nodes which are not required in order to make the decisions. So pruning is thus the process of removing that particular unnecessary nodes. A too large tree increases risk of overfitting. Exactly, the tree has to be uh, properly fitting. It should not have the risk of overfitting, and a small tree may not capture all important features of the data set. So having um, a too large tree and too small tree is something not useful. And therefore, a technique that decreases the size of learning tree without reducing accuracy is known as pruning. There are two main types of tree pruning technologies. One is a cost complexity pruning, the other is reduced error pruning. Now let's have a look at the advantages of decision tree. So it is simple to understand that is as it follows the same process which a human follow while making any decision in real life. And then it can be useful for solving decision related problems. It helps to think about all the possible outcomes for a problem, and then here it requires less requirement of data cleaning compared to other algorithms. And the disadvantages of decision tree is it contains lots of layers, depths, which makes it complex. It may have an overfitting issue, which can be resolved by using the random forest algorithm. So if the size of the trees are too large, then we may encounter overfitting issues. And for more class labels, the computational complexity of decision tree may increase. Now let's hop to Jupyter Notebook and check out the example of decision tree classification algorithm. I'll see you there. Now here I'm in my Jupyter Notebook. So here I'm going to create a new Python file and let's name this as decision tree. Decision tree classifier algorithm, and then let's write a heading here saying decision tree classifier algorithm. So here let's try to mark down what exactly decision tree is. So here I say a decision tree is a flow chart that can help you make decisions. Based on previous experience. Now, for example, here let's mention in the example the person will try to decide. Here I say a person will try to decide if he or she should go to a comedy show or no. Comedy show or not. So here we'll be using a file, let's say data.csv. Now let's have a look at the working of this. So first we will be reading the dataset using pandas. So here I do import pandas as pd, and then data frame equals pd dot read underscore csv, and then pass in data dot csv, and then let's check the data frame. Alright, so this is our data frame, data.csv. Here we have columns like age, experience, rank, nationality, and go. So here if you see, age is numerical column, experience is also numerical, rank is also numerical, nationality is object column, and go is a categorical column having values like yes or no. Let's also deep dive. Let's do df dot head. So it's a very small data set. df.head will give you the first five values, and then df.tail should give you the last five values. Let's also get the information about the data set by doing df.info. So this should be giving you number of columns or names of all the columns, non-null value count, and also the data type of the columns. So if you see here, we have column names, non-null count. So here we do not have any missing values in our data set. And if you notice, nationality is also object and go is also object. So these two columns are non-numerical, meaning they are having string values, whereas age, experience, and rank are numerical columns having integer values. So in order to make a decision tree, all the data has to be numerical. So if you notice here in the go column, we have object values as yes or no. So we have to convert the non-numerical columns like nationality and go into numerical values. So here we'll have a markdown saying to make a decision tree all data has to be numerical, and then we have to convert. In this example, we have to convert the non-numerical column like nationality and go into numerical values. So here pandas has a function known as map. So here I'll write another markdown to say pandas has map function or map method that takes a dictionary with information on how to convert the values. Let's say for example, if I have to convert UK to 0 and USA as 1. So I'm actually changing the value for uh, the countries uh, as numerical. Let's say USA is 1 and N is 2. Here we are converting the value of UK to 0, USA to 1 and N to 2 in order to um, convert the non-numerical column nationality into a numerical column holding numerical values. Okay, so now let's say here we will write a code to change or convert the non-numerical data into numerical data. So here I do b equals, let's say UK is 0 and then we have USA as 1 and N as 2, and then data frame of name of the column is nationality equals df of column name is again nationality here dot map. I want to map this dictionary to my nationality column. So there is a typo here. Alright. So you can see here I'm mapping this dictionary holding key and value pairs for countries, and then D equals, let's do the same for column go. Column go is having only two values, yes or no. So for yes, I want 1, comma for no, let's say 0. Okay, df of go equals df of go dot map of D, and then we will check our data frame. There we go. You see our columns nationality and go have now become numerical. They are not non-numerical. I can also go and again check by doing df of info. So here you can see all of them are in 64, the data type. Initially it was showing object when I previously checked df.info. Now it has been changed to numerical. Now we can actually go and change our feature columns from the target column. So here I'll write a lockdown. Then here we have to, in the markdown I'm going to write, we have to separate the feature column from the target column. So this is feature columns from the target column, and the feature columns are the columns that we try to predict from. And the target columns, a target column is the column with the values we try to predict. So here, let's say X is the feature column and Y is the target column. So let's create a variable by name features. Features is age and then experience, comma rank, and the nationality. Alright, x equals data frame of features, and our y variable is df of go. This is our target variable or target column. Then I can simply go and check my x and y. This should be features, and let's hit enter. Okay, it says y is not defined. Okay, y should be small, and there we go. You see, this is how my output looks like. So based off the index, that is giving me the value for the column go. Based on this features index, it's giving me the value for column go as 0 or 1. And now we actually have to build a decision tree. So here let's write a markdown that says, now we can create the actual decision tree. And then fit it with our details, and then start by importing the modules we need. So let's first import pandas as PD, and then from sklearn, let's import tree, and then also from sklearn, dot tree, we will import decision tree classifier, and then we will import matplotlib dot pyplot as plt. Alright, now we have to create our data frame. Let's say df equals, let's read the data set, pd dot read underscore csv, and then passing the data set name data dot csv, and then d equals, that is conversion of non-numerical column into numerical. So this is 0, this is USA is 1, and then we have n as 2, and then df of, let's say this is nationality, equals df of nationality dot mark t. Similarly, we will do for the go column. Let's say s is 1 and no is 0, and then we will again map this to the go column. So here I say go equals data frame of go dot map of d, and then let's do features equals, let's put in all the features, age, experience, rank, and nationality. And then df of, let's pass in features and assign this to variable x equals, and then y equals df of column go, and then we'll create a tree, d tree decision tree equals decision tree classifier, and then d tree equals d tree dot fit x comma y, and then let's do tree dot plot underscore tree, plot D tree, comma, passing the features as feature names. So here I do feature names equals features, and let's check, and there we go. This is how the decision tree looks like. So here you see here we have, let me increase the size. Now let's read and understand the different aspects of this particular decision tree. So we first have rank less than or equal to 6.5, means that every comedian with a rank of 6.5 or less will follow the true arrow to the left, and the rest will follow the true arrow to the right, and rest will follow the false arrow to the right. So rank less than or equal to 6.5 means that every comedian with a rank of 6.5 or lower will follow the true arrow to the left, and rest will follow the false arrow to the right. And if you see, we have value, and then we have Gini equals 0.497, which refers to the quality of the split. And it's always a number between 0.0 to 0.5, where 0.0 means all the samples got the same result, and 0.5 would mean that the split is done exactly in the middle. And then we have samples equals 13, means there are 13 comedians left at this point in the decision, which is all of them, since this is the first step. Value 6 comma 7, which means that of these 13 comedians, 6 will get a no and 7 will get a yes, or 7 will get a go. The next step contains two boxes, one box for comedians with a rank of 6.5 or lower, and one box with the rest. And then we have a true 5 comedians in here. So here the value for Gini is 0.0, which means all of the sample got the same result. And then samples are 5, means that there are 5 comedians left in this branch, and that is 5 comedian with a rank of 6.5 or lower. Then we have value equals 5 comma 0, which means 5 will get a no and 0 will get a go or yes. Now let's see how to predict values. So here I'm going to create a new cell with markdown predict values. So here I say we can use decision trees to predict new values. Let's say the example is should I go and see a show starring 40 years old American comedian with 10 years experience. Here is say with 10 years of experience and a comedy ranking of, let's say, 7. Okay, so how do we do this? Here I can make use of the predict method. So here I do print, then d3 dot predict and mention these values. That is 40 years old American comedian, 10 years of experience, 7 years of ranking. Sorry, 7 is the ranking, and then 1, enter. So say it says 1. So here it is print 1 means go and 0 means no. I can also write that print. Here I say 1 means go and 0 means no. Yes. All right. Now, what if the comedy rank was 6? So, here if I go and write a markdown, what if the comedy rank was 6? So, here I can do, let me change this to markdown. Yes. And then let's say print d3 dot predict and then pass in 40 comma 10 comma 6 and 1. So here 6 is the comedy rank, so this should be giving me 0 stating no. Let's figure out why it is giving an error. So it says expected 2D array got 1D. Okay, because I have not used the brackets, so here I'm supposed to use two-dimensional array. There we go. You see this gives me value as 0. So here you can see that if you pass the same data to decision tree again and again, you will see that the decision tree will give you different results. If you run it enough time feeding with the same data, this is because the decision tree is not 100% accurate. It means it will not give us 100% correct answer. It is based on probability of an outcome. And that is why the answers will vary. So that was all about decision tree classifier algorithm. Uh, That's all for this session. Hope you enjoyed this session. We'll see you in the next.